Hello, Chemistry 10HH students. I'm on the third page of your study guide. I will talk about density. So this is really a unit conversion. You should know that there's 1,000 milliliters in a liter. And you should also know that I did that wrong, my bad. And you should also know that a cubic centimeter is equal to a milliliter. And then from here, it's just division. You didn't have to put it into scientific notation, but it did need to have two sig figs. Okay, so first I just converted kilograms to grams because my density has it in grams, and then I'm actually going to use the density from the beginning of the problem since I'm looking for it in liters anyway. And then I'm going to round this to 3 sig figs. So that's a whole lot of liters of helium. For this problem, I'm going to use the density that was my answer to part A, just because I already have it in cubic centimeters and I'm looking for it in grams. I'm looking for 5 sig figs. So that is why I put the dot at the end. So this is more of a conceptual problem. So if I'm cooling it below its boiling point, it's going to become a liquid. That's going to increase the density because I'm going to have more heliums in a smaller amount of space. Right, so everything has wavelength properties. We cannot observe the wavelength properties of a baseball in flight because of the baseball's high mass, which will result in a wavelength that is not on the electromagnetic spectrum. So we talked about this in class. It's called the de Broglie wavelength. You're not going to need to do any calculations with it, but one thing to remember is that equation, the mass was in the denominator, meaning a higher mass leads to a small wavelength, something so small, in fact, that it is not on the electromagnetic spectrum.